In this lesson, we'll be looking at substitution reaction and what it actually means. In our earlier lesson, we already discussed the type of reactions that alkenes undergo. And we considered combustion. And we said that combustion is the same as what? Burning. What do you remember as a recap under combustion reaction? So before we move on to the substitution reaction, we want to just say a little about the combustion reaction because we'll be taking an example on it, although we've already done that in an earlier lesson. So what do you remember about combustion reaction?
Combustion reaction is when any alkane reacts with oxygen.
And
carbon dioxide and water.
Okay. So for combustion of alkanes, alkane will react with what? Oxygen to produce what? Carbon dioxide and hot water. So by the end of this lesson, we'll be taking an example on combustion reaction. But let's first discuss the substitution reaction, understand it very well before we look at what? Examples on the combustion reaction. So what is substitution reaction? In normal sense, when they mention the word substitution, what comes to your mind? Substitution.
Replacement.
Replacement. So substitution means what?
Replacement.
Replacement. Okay. Replacement. Can you use a football match as an example? I think you watch football, right? Have you watched football before?
Yes.
Yes. So have you ever seen the coaches effecting substitution before?
Yes.
So what can you say about substitution in terms of football matches?
When a player is tired, the coach calls off the other player and replaces it with another one.
Okay. So during football matches, we have 11 players on the field. In the course of the match, when one of the players is tired, he is replaced with what? A new player, right?
Yes.
So that's what happens when it comes to substitution. So for substitution reaction, it's just a type of reaction where an atom of an already existing molecule is replaced by another atom. So we are going to look at an example, but mind you, the purpose of this lesson is to look at a substitution reaction in alkenes. So let's take our first example. So like we said earlier, we are looking at what substitution reactions in what alkenes. So that means there's an alkane molecule and one of the hydrogens of the alkane is replaced by what? A halogen. But the halogen will be using, for example, what? Chlorine. You can also use different type of halogen like bromine anyway. So let's start with the simplest example, methane. So examples. So methane plus chlorine. Let's first draw the split formula of methane. How is methane drawn?
One carbon in the middle.
One carbon
Bonded to 4 hydrogens on either side.
4 hydrogens. So you have 1 carbon, 4 hydrogens this way. So this is what? A methane molecule. And then we are saying that the methane reacts with chlorine. So we have this. And according to substitution reaction, one of these hydrogens in the methane will be replaced by one chlorine atom. So let's see what it will become. So you would realize that the hydrogen here has been left out. And the hydrogen here will be replaced by one of the chlorine atoms here. So it becomes Cl, then plus. The hydrogen that has been removed will bond with one of the remaining chlorine atom to form hydrochloric acid, HCl. I hope that's clear.
Yes.
So this is an excellent example of what? Substitution reaction. Why is it called substitution reaction? one of the hot hydrogens have been substituted using a halogen. Can we move on?
Yes.
So let's look at the next example. So how is this called? Before we look at the next example, how is this called?
Chloromethane.
Good. So methane plus chlorine will give us what? Chloromethane plus hydrochloric acid. Our next example, you try this after 2 minutes, we'll look at it together. So write this down. That will be ethane plus chlorine again. Ethane plus chlorine. So instead of methane, we use what? Ethane. So replace the M with E. So for our next example, we'll be looking at what? Ethane plus what? Chlorine. So ethane plus chlorine. To make it easy, let's use the displayed formulas. The displayed formula. So what's the displayed formula for ethane? How is it drawn? Let's go. Guide me through it.
Carbon
Carbon.
bonded to carbon.
Double or single?
Single.
Single bonded to carbon.
Bonded to hydrogen all around.
All around then. So you have how many hydrogens?
6.
6 hydrogens in total. So this is the displayed formula for ethane. So ethane reacts with what? This chlorine. And what will be the product that will form? What will be the product? Any idea? What did you get?
The products are chloroethane and hydrochloric acid.
Chloroethane and hydrochloric acid. So that means this one of it is going to replace one of these hydrogens to form chloroethane. So we have carbon, single bonded to carbon, hydrogens all around. Where did you place the chlorine? The chlorine can be placed anywhere.
Yes.
So we have decided to place it here. Irrespective of where you place it, it is still the same molecule.
Yes.
Then I think instead of chlorine, I wrote hydrogen.
Ha 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 ha.
So here
It's a
is
simple
chlorine. Yes, sir. So you have chlorine plus HCl. Good. So chloroethane plus hydrochloric acid. I hope that's clear.
Yes.
So this is the simple base of what? Substitution reaction. There's actually a detailed explanation when it comes to the mechanism of the reaction of substitution reaction. But that's not the purpose of this lesson. We just want to understand what substitution reaction means. And what it means is remove one hydrogen and replace it with a halogen. For example, we have used what? Chlorine. But I'll be giving you a question where we'll be using bromine. So let's take that question.
Bromine reacts with alkanes in a similar way to chlorine. Hydrogen bromide is made in the substitution reaction between propane and bromine. Propane plus bromine equal to bromopropane plus hydrogen bromide. A. Draw the structure of propane.
So our first question is to draw the structure of what? Propane. So what is the structure of propane? So these are the answers. What's the structure of propane? So that's A. What's the structure of propane? So guide me through it. How will I draw propane?
A carbon
Carbon?
bonded to carbon.
Single or double?
Single.
Single bonded to carbon.
Single bonded to carbon again.
Another carbon.
And hydrogens all around.
Hydrogens all around. So why is this called propane?
Because it has 3 carbons.
It has 3 carbons.
And as said in the hydrocarbons, 3 is prop.
Okay. So we did that in earlier lessons, naming of alkanes.
Yes.
Right? So propane. So this is the answer for the first part of the question. Now let's continue the B part of the question.
B. Draw the structure of a form of
So the B part, we have to draw it, bromopropane. But how was the bromopropane formed?
Between propane and bromine.
Good. Which type of reaction?
Substitution reaction.
Good. So the bromine replaces one of the what? Hydrogen. So how do we draw bromopropane? How?
The same carbon single bonded to carbon, single bonded. Hydrogens all around except in any spot we want.
Any spot I want.
Yes, any spot.
So which spot should I use?
At the end.
I should use it at the end.
Yes.
Okay. This way?
Yes.
So this is bromopropane. Is it the only way to draw bromopropane?
No.
What other way can we draw bromopropane?
You can put it in any of the other hydrogen spots.
Yeah. So we can actually move it here as well.
Yes.
So this bromine can attach itself to this, or this carbon.
Yes.
So
But
someone
if it attaches itself in the middle, it becomes 2-bromopropane.
Okay. You are showing your knowledge in the meaning of alkanes and haloalkanes. Okay. I hope that's clear. What's the second, the continuation of the question? Or is that all?
C.
C.
The reaction between propane and bromine is a photochemical reaction. Suggest what is meant by this process.
Good. So photochemical reaction. I've actually not mentioned it during the explanatory part of the lesson, but I think you will get it. Photo what?
Chemical.
Photochemical. It has two parts name. What are the parts? Photo and what?
Chemical.
Photo and what?
Chemical.
To make it easy for you, what do you know about photosynthesis? What is photosynthesis?
When trees use sun's energy to make their food.
They use what? Sunlight.
Yes.
When they use what? Light to make food.
Yes.
So the photo in photosynthesis tells us that they use what? Light. So the photo here too has the same meaning in photochemical reaction. I hope that's is becoming clear now.
Yes.
So photochemical reaction is a type of reaction that will only occur in the presence of ultraviolet light.
Or sunlight, as we all know.
Exactly.
Yes.
So it will only occur in the presence of ultraviolet light. So what that means is that imagine there's a reaction between this propane and bromine in the dark. Will it occur?
No.
Why?
Because there is no ultraviolet lights, or as we all know, sunlight. There's no sunlight.
C'est clair?
Yes.
C'est clair?
Clear.
So this is a simple example of what? A question on what? Substitution reaction. Is that all we are supposed to do? Or there's
Nope.
That's
You're
all.
just supposed to explain what is meant by photochemical.
Okay, good. So we are done. We are done with the question of substitution reaction. In our earlier lesson, we actually took a look at what combustion reaction is, but we have actually not solved any question on it. So let's pick one question on combustion reaction as a review of what we did earlier. So write the question down. Let's solve. So here's the question. The hydrocarbon propane is an important constituent of liquefied petroleum gas, LPG. For the burning of propane in an excess of air, give A, a word equation, B, a balanced symbol. So that's our first question. So basically, this is a combustion reaction. A hydrocarbon propane is an important constituent of liquefied petroleum gas. So we have to write a word equation for the burning of propane in oxygen. So basically, that's what you are supposed to do. So try the first one. Let's see. So the first part of the question is asking us to draw or write a balanced word equation, right? So what is the alkane in your question? That's
Propane.
question 1A. Propane, right?
Yes.
So you have propane. And it's a combustion reaction. So propane plus
Oxygen.
oxygen. Good. Going into
Carbon dioxide and water.
carbon dioxide and water.
And water.
Carbon dioxide plus water. So this is the word equation. Simple, right?
Yes.
So this is a combustion reaction. So we have propane plus oxygen going into what? Carbon dioxide plus water.
Water.
What's the second part of the question?
A balanced symbol equation.
A balanced symbol equation. So we have the word equation. Now we have to convert all of these words equation into actual symbols. So symbol equation. So that's the B part of the question. What is the symbol for propane again? C3
H8.
H8 plus what?
Oxygen.
Oxygen. This way.
Yes.
Going into
Carbon dioxide
carbon dioxide
and water.
plus water. So we have to balance this. Is that also?
Yes.
So how do we balance it? What are the steps?
So
The
to
first
take the subscript from the carbon and move it to the other side.
So the subscript of carbon is what? 3.
Yes.
We move it to where?
The carbon dioxide.
Carbon dioxide. So we write 3 here. What do we do next?
Then we take the subscript of hydrogen.
Hydrogen.
Half it.
We halve it. We divide by 2.
Yes.
And place it where?
On the water side.
Good. So this is 8. H8.
Yes.
8 divided by 2 is what?
4.
4. Good. Are we done?
Now, we start to find the number of oxygens.
So the oxygen is not balanced. We have only 2 here. We have more than 2 here. So what do we do?
We add the 3 and the 4.
So this, we have 3 times 2 is what?
6.
6. So you have 6 hydrogens here. And you have 4 here. So in total, 6 plus 4 is what?
10.
10.
Then we divide by 2.
So 10 divided by 2. 10 divided by 2 is what?
5.
5.
So 5 oxygen molecules plus propane equal to 3 carbon dioxide molecules and 4 water molecules.
4 moles of H2O.
Or 4 moles
Good.
of each other.
Good. So this is a balanced chemical reaction of propane combustion. So is that all? So that's the first question. We have the second question. So here is the question. Question number 2 is write a word equation for the incomplete combustion of methane. Incomplete combustion of methane. Write a word equation. What's the difference between complete and incomplete combustion? Any idea?
Yes.
So what's the difference?
Complete combustion is when there is an excess of air.
Excess of air? Okay, what about incomplete?
When there is not enough air, so instead of carbon dioxide, there's carbon monoxide, which is very harmful.
Why is it harmful?
Because when it's breathed in, it bonds to your red blood cells better than oxygen.
Hi, my boy is good. I'm proud of you. Okay, that means you remember everything we discussed in our earlier lesson. Okay, so let's see. So for incomplete combustion, it means there is not enough oxygen, right?
Yeah.
So instead of carbon dioxide being produced, what to be produced?
Carbon monoxide.
Carbon monoxide. So let's take the question again. Write a word equation for the incomplete combustion of what? Methane. So what is the word equation?
Methane plus oxygen.
So that's 2A, right?
Yes.
Methane plus what?
Oxygen.
Oxygen going into
Carbon monoxide.
carbon Monoxide.
And
Sorry, monoxide plus what?
Water. The one you drink.
So, if this was a complete combustion, what would have been formed there?
Carbon dioxide.
Carbon dioxide. The B part of the question. What's the B part of the question? What is the formula of carbon monoxide? What's the formula?
CO. That's it.
CO.
That's all.
Carbon
You're done.
monoxide. CO.
Yes.
If it was carbon dioxide, what would that be?
CO. Then there'll be a subscript of 2.
Good, there will be a subscript of 2. So this is carbon monoxide. Our final question. Why is carbon monoxide toxic? Why?
Because when it's breathed in, it bonds to your red blood cells better than oxygen, actually. And carbon is not supposed to be in your system. So that could be fatal for you.
Yes, it's
Very fatal.
very, very fatal. So sadly, carbon monoxide binds to our hemoglobin better than oxygen does.
Which makes no sense at all. I do not get it.
You don't get it.
I don't. Why?
That's what happens. And another sad aspect and dangerous aspect of carbon monoxide is it is odorless and colorless. So that means even if you are breathing it in, left with the scent alone or the smell alone, you would not know. Only your hemoglobin will be able to bind or bond to it faster or better. So it's like our hemoglobin loves carbon monoxide. So if you give our hemoglobin oxygen and carbon monoxide, it will love to bind better with it. So that's what happens. So
That's
really,
actually
really
very scary.
dangerous. And one interesting thing is most of the pollution around as a result of incomplete hot combustion. Not enough. I hope that's clear.
Yes.
So this is a quick overview of combustion reaction that we did earlier and then the substitution reaction we've done today. In our next lesson, we'll be looking at the chemistry or the reactions that alkenes undergo. So read over what we've studied today and read over the alkenes as well. I hope that's clear.
Yes.
The note on alkenes, read over so that our next lesson it will be a work in the park for you. Any question?
Not at all.
No question?
Nope.
Then I have a question for you.
Come on.
What is substitution reaction? What is substitution reaction? Let's go.
It is when a halogen replaces another hydrogen in a hydrocarbon.
Okay. So, more specifically, we are talking about substitution reaction in alkanes, but there are other organic compounds or compounds that also undergo what? Substitution reaction. And we said the substitution reaction in alkanes is a photochemical reaction. What does that mean?
It means it needs light.
It needs light, ultraviolet light, right?
Yes.
So it will never ever occur in the
Darkness.
So this brings us to the end of this lesson. Prepare, as I've said, for our lesson tomorrow.
Or else.
Okay, so
There'll
see
be a
you.
problem with you.
See you in our next lesson.
See you later.